In this video, we're going to be looking at using Excel to convert between the normal distribution and our x and our z and our percentage values and all of those. So in this one here, it's very similar to our prior examples. This one hopefully is the recap that you can watch to learn all the formulas at once. We can go ahead and see that there are 4 formulas that we can use. So we have equals Norm.s.dist. We have equals Norm.dist. We have Norm.s.inv and Norm.inv. So let's look at the first 2. So in this one, our inputs are a z-score and a 1, meaning a cumulative. We want the area under the curve or the probability to be returned. And then this one here has an input of an x value, a mean, and a standard deviation. So in this one, we're going from x to percentage. In the top one, we're going from z to percentage. So the pattern is you use .s dots in there, so norm.s, norm.s, when you're dealing with z to percentage or percentage to z-score. You use the Norm.dist or the Norm.inv when you're going back and forth between x to percentage or percentage to x. So when do we use the .dist and the .inv? Well, if you start with a value and end in a percentage, you start with a value and you're going up to the probability or the percentage, you're going to use a .dist. If we're starting at the percentage or the probability and are working our way to either our z or our x score, you're going to use the .inv. So if our input is a probability, we're going to use a .inv. If our output is a probability, we're going to use a .dist. So those are the 4 formulas. So let's look at an example of these right here. The cue to know is that when you use any of the formulas in here, the Norm.s's, it always does the area in the left tail. So for example, on this one, z is less than 2.3. So I'm going to go ahead and say, well, I'm not dealing with x scores, so I'm going to say z is less than 2.3. So let's go ahead and say 2.3. This is approximately where our z-score falls for that. We're going to highlight in, z is less than there. We're going to go ahead and put in that our value here was 2.3, and we're going to work from there. So the process is you're going to enter the z value, and it's going to return the probability in the left tail. That's exactly what we're after in this one. So if we put in the z value, it's going to return the value in the left tail. So let's do that. So equals Norm.s.dist. My z-score is a 2.3, comma 1. We're going to get a 98% there, so 0.9893. So in this case, we found that this value right here is 0.9893. So reading that from a summary conclusion, from the top down, 98.9% of our values are going to be 2.3 standard deviations away from the mean or less. So let's go ahead and look at the other version of it. So what happens if you're dealing with a greater than sign? What they're asking for is what's in the right tail. So let's use the same one here. So we're going to use 2.3 again. So if we do 2.3, and we want to know what's in the upper tail, how do we get that? Well, by logic of the version up here, it's just going to be 1 minus that, correct? So let's go ahead and put that in. So if I do put in 2.3 equals Norm.s.dist, I'm going to come up with 2.3 comma 1. I certainly do. I come up with 0.9892. I come up with the same thing. So it told me the area from here to here as being 0.9893. So to get the answer, we're going to use the complement rule. So 1 minus 0.9893 and that is going to equals 1 minus 0.9893, 0.100107. So there's a 1.1% chance that our value is going to be above 2.3. So if you're doing a greater than, instead of doing it equals Norm.s.dist, you can do that, but your answer is going to be equals 1 minus Norm.s.dist with your formula because you needed to convert it over to a left tail. Let's go ahead and look at another example then. So we're going to go ahead and say, let's keep working between the percentages and the z values at the moment. So what is the probability? Well, the probability of z between less than some number is 25%. So we could have read it this way. 25% of our values are when z is less than some score. Well, knowing what we know about the z-curve, that the normal curve, 50% is here, and if I'm dealing with the left tail and I want 25% in the tail, that we're going to find ourselves somewhere in here. And in this scenario, we know the probability. So unlike the last two, we know the probability. Let's fill this in first. So we know that this one is 0.2500. And how do we get the corresponding z value to go with it? So to get that, we're going to use equals Norm.s.inv. We're going to enter our probability as 0.2500. You could have put 25 with the percent key as well. It's going to come back with negative 0.67. So negative 0.67. So when we looked it up, we just found that that value was negative 0.67. Well, having done that, we entered the probability in the left tail to find out what the z-score was. So in this one, what's the probability that z is going to be greater than 75%? So if we were to graph this, greater than 75%, so 75% is going to be in our value up here. So let's go ahead and, this is going to be 75%. So we have our 75% there. In order to do this, we need to enter the probability in the left tail. So what we need to do is we need to enter this number into our equation. So 1 minus 0.75 then is obviously going to be 0.2500. So let's go ahead and say equals Norm.s.inv. Because we have to enter the probability in the left tail, we're going to enter 0.2500. We could also put 1 minus 0.7500. It doesn't matter. It will do the math for you. And it's going to return negative 0.67. So there's a 25% chance that our value is going to be less than negative 0.67 standard deviations from the mean. And there's a 75% chance that it'll be more than. Let's go ahead and look at the next two examples then. So going between x and percentages and x values. This one actually has much more use in the real world because very rarely do we actually use z values except for in the tests that we'll be doing in the next few chapters, so they are good to know. So let's go ahead and clear our graph here. So I want to start with a blank slate. In this case, if we were to do it the old-fashioned way, we'd go from, like I said, percentage to x to z, or to z to x, or from x to z to percentage, depending on what we're working with. So in this one, we'd go from x to z to percentage. We're going to be able to jump directly from x to percentage without converting any z-scores. So we have an exam here, and this exam is worth 35 points, and 25 of those points finds us at our average. So our average is 25. Having said that, we want to find the probability that a student is going to score less than 20 on that exam. Excuse me, less than 20. What's the probability somebody's going to score less than a 20 on that exam worth 35 points, then the average was 20? So let's go ahead and fill in the area there. Oh, look, lo and behold, we already have something that we're going to be looking for the left tail, so it's going to actually give us our answer. So we know that our x value is 20, right there. So how do we go between these two now? We're going to let Excel do the work for us. So we're going to put in equals, enter the value. So Norm.dist. So our value is 20, x is 20, our mean is 25, our standard deviation is 2, 1, and when I do that and I enter it in, it tells me that the probability is 0.006. So this value in here is 0.0062. Having said that, let's go ahead and put that into real world terms. So there's only a 0.6% chance that a student taking the exam should have scored less than a 20 on that exam. That's provided we looked at the exam historically and it is normally distributed, etc. So if we knew it was normally distributed and you had several people score low, it would cue you that there would be a problem. Let's go ahead and look at another example here. So the probability is between 20 and 30. So probability between 20 and 30. So we're going to go here of between 20 and 30. And we want to know the probability between. So we want to know this area here. Essentially what we're going to do is we're going to put in the values and we're going to come back with two of them. So when we put in the value for 30, it's going to give me this value. When I put in the value for 20, it's going to be this one, and we're going to subtract the two probabilities. So let's go ahead and do that. So equals Norm.dist with 30, comma, the mean of 25, comma 2, comma 1. So mean of 25, standard deviation of 2, and it's always a cumulative. We want to know the probability, so it's a comma 1. I get a 99.34% chance on that one. So this one right here is a 0.99. I'll put that over here. So 0.9934. Let's go ahead and look at the next one. So if I go ahead and put in equals Norm.dist with our 20 value, our standard deviation of 25, and our cumulative effect of, excuse me, a standard deviation of 2 with a cumulative effect with a 1, I'm going to get 0.0062, which is what we just did in the last example, 0.0062. So this value here was 0.0062. So to get our answer, we are going to say, well, we're going to take 0.9334 and we're going to subtract 0.0062. So the answer to that is 0.9934 minus 0.0062. So we have a 98.7% chance. So this area in here is now going to be a 0.9872. So there's a 98.7% chance the students should score between a 20 and 30 on the exam. So last and final example. We're going to go ahead and once again clear this one. So new. And we're going to look at this version of it here. So if we want to go from percentage down to x. So we're going to go percentage down to x. So we're going to enter the probability in the left tail, and it's going to return the x value associated with it. So the probability that x is greater than some number is 67%. So we could read that backwards. 67% of the values are going to be more than some x value. Well, once again, we know that 50% is on each side, so if 67% are going to be more than, we're going to find ourselves over here. So 67% of the values, so this range in here is 67%, fall between some test score, and remember, our mean is 25, right? So something that's going to be below a score of 25 and all the way up to a 35 is the highest score. So how do we do this one? So we need to enter the value in the left tail. Well, to get the value in the left tail, I'm going to need to want to do 1 minus 0.67, which is going to give me 0.3300. So you add those two together, 0.67, you get to 100%. So equals Norm.inv. Area in the left tail is going to be a 33%. Our mean is 25. Our standard deviation is 2. That's all that we need to enter on this one. And it's saying that the score is 24.1. So our x value associated with that is going to be 24.1. So 67% of the students should have a score of 24.1 or higher. Let's look at this next one. This is a little bit different way to look at it. I'm trying to find 50% of the values, and I'm going to go between some negative a value and some positive a value. So that's just another way of saying I'm going to go equidistance on both sides of my mean, and I want to get 50% of the values. So if I want 50% of the values, and I know that this is 50% of the values then, 0.500. And I need to figure out what the two things are at the bottom that are associated with that. So what is my lowest score on my exam to be in that middle 50% and my upper score to be in that middle 50%? So to do this, we're going to say, well, that's 50%. That means that each side of this is 0.2500. So we're going to divide it by 2 as step number 1. And then we're going to want to know what value that we're going to be looking up in Excel, because we always have to enter the left tail. So when I enter the lower one to get the value associated with that, well, knowing how much is on each side, this value here is going to be 0.2500, and this value is going to be 0.2500. So 25% of the values up to this point. So that'll give me my lower boundary. So equals Norm.inv. I want my lower 25%, how much is in the left tail, comma my mean of 25, my standard deviation of 2, and it says that 23.65 is the value on the lower side. So 23.65 is this value right here. What's my upper value? My upper value, we need to go from here up to there. So if I add all of these, 25%, 25%, and 25%, I'm going to catch myself at 75%. It's 0.7500. So the value I want to enter into Excel, because I need my left tail to enter, equals Norm.inv. And we want 75%. And the mean is 25 with a standard deviation of 2. So 26.34 is going to be the next value, 0.35 if we round. So 26.35. So the middle 50% of people will score between a 23.7 and a 26.4.